Alright people, so let's take a look today at another technique from our Mitre-Attack series, and that is service stop T1489. So this is one of those techniques that are so simple that you might not consider them in your security considerations. So for that reason I would like to cover this today. So let's switch back to editing mode. Today we have Saturday night, the 3rd January of 2026, and I'm going to, as usual, copy that real quick, and also feel free to read this while I copy some of the procedures down there. Don't need a whole lot of procedures, I think, but just a couple like this. There we go, that's more like it. We have a little bit of this, and then I copy a little bit from the middle. Something like that. Okay, that's good enough. So let's switch back to reading mode real quick and then take a look at this. So we are here in the field of impact, in the kill chain step, let's say, of impact. That's at the very last part of our adversary life cycle. So after the adversary has gained access to your system and has created all the persistence that is needed, defense evasion worked, a lot of things worked, and now the idea is to stop services, and this might be one of the impacts. So the affected systems are as usual ESXi, infrastructure as a service, so cloud containers and so on. And then you have the typical operating systems, Linux, Windows and Mac OS. Okay, then impact type they have here as well, so it's availability. Obviously you cannot access a service if it is stopped. As a result of that, we can say it's not confidentiality, it's not integrity, it's availability. I like that they added the impact type here. I didn't pay attention if they had this in our last overview, so I'm pretty sure they don't have the impact type, simply because many attacks cannot be clearly mapped to one. The contributors are again cardinal ops, we read that name oftentimes, and last modified as recently. So let's see what they say. Adversaries may stop or disable services on a system to render those services unavailable for legitimate users. So to render we have the what, so legitimate users shall not use the services, and then stopping critical services or processes can inhibit or stop response to an incident or aid in the adversary's overall objective to cause damage to the environment. Yes, this is absolutely true. So for example, you can disable the logging and monitoring on the systems, and as a result of that the response will be much later than usual. Another way you could manipulate the endpoint detection and response system in such a way that it doesn't do anything. Yeah, so there are a lot of the easiest way that is, let's say at the bank, if you disable the camera systems. As a result of that, the attack can happen without being visible to the security personnel. So yeah, stopping services is quite a big deal. What else do they write here? So adversaries may accomplish this by disabling individual services of high importance to an organization, such as MS Exchange. Yeah, so that's emailing, right? which will make Exchange content inaccessible. In some cases, adversaries may stop or disable many or all services to render systems unusable. Yes, so either you render them unusable, or you just disable that what is needed to facilitate a response to your attack, but you leave all the other services intact, so nobody notices for a long time that critical services have been disabled. Yeah. Then service or process may not allow for modification of the data stores while running. Yeah, that's obvious. So while a program is reading a file, you can't manipulate it. So you might want to stop the service. Again, a banking example. Then modify the database and restart the service. If the service is not able to recognize the change, there will be integrity issues. Service processes, this adversaries may stop service or processes in order to conduct data destruction or data encrypted for impact. Yes, so encrypted for impact we had, that's ransomware. We see also at the bottom Medusa ransomware that catched my eye immediately. And so then you have SQL servers and ESXi infrastructures that are also affected. Threat actors may also disable or stop servers in cloud environments. And then there are some examples for cloud environments. Okay, and as you can see, Akira, that's a classic ransomware that is still active. I've seen it in the wild. It's a sad thing if companies end up encrypted without a good backup. Everdon looks for and attempts to stop database processes. Avos Locker has terminated specific processes before encryption. Okay. Then Lockback can kill processes and delete even services. Maze has stopped SQL. Medusa Group has terminated services related to backups. That's quite smart. So you disable the backup and then you encrypt everything. Yeah, fascinating. Sometimes I ask myself, what if these hackers would put their talent to use for something not destructive? But that's obviously naive to think like that. Okay, so let's copy this and jump back to the reading mode. Let's see what mitigations exist. So network segmentation. Yes, so if you disable a service, the idea is that when the network is segmented, it only affects that small segment of a network. There even exists the trend right now to do micro-segmentation. That's a lot of effort, but the smaller the segments are, the less the damage that is caused by any attack. So here segmentation works. Out-of-band communication channels. So develop and enforce security policies that include the use of out-of-band communication channels for critical communications during a security incident. Okay, so that's like not the mitigation against disabling the services, but to remain responsive during an incident. Then restrict file and directory permissions. Yes, of course. Restrict registry permissions. That's also something that can stop services. In the registry in Windows, that's a Windows thing, there are sometimes entries 0 or 1. 1 means enabled, 0 disabled, so you can manipulate certain registry entries, and as a result, when you restart your computer, these services wouldn't be running. That's what a virus does as well. And the last thing is user account management. Limit the amount of accounts that is even capable to stop critical services. That's all absolutely right. Nonetheless, I witness quite often that these simple techniques are not followed. So they want to detect some fancy ransomware, some hashes, some whatever, but the simple looking out for a service that has been stopped, that's sometimes too much. Okay, let's take a look at detection now. So if you want to take care of this from the SOC. So adversaries disable or stop critical services. Then you have some examples, as I mentioned before, antivirus endpoint monitoring, then using native utilities or API calls, often preceding destructive actions, and they are the T numbers. The behavior chain is elevated execution, stop service, and then follow up file manipulation. Okay. Then you have system CTL, which is just specific for Linux as far as I know. Then you have launch CTL, another very specific thing, and virtual machine behavior chains. So the chain always start, if you see here's sudo, yes, that's Linux for sure. So you stop a command in all cases here, and at the end there's some sort of file manipulation. So the pattern is always the same. Let's mark it down. Just the word behavior chain. That just shows that Mitre has quite the idea how to detect patterns, and that's our job. That's our job. One of my former bosses once asked in one of the meetings, what is the difference between humans and animals? And obviously there are many differences, but the main difference comes down to this. Humans are capable to predict the future, and they are capable to detect patterns in life and react upon these patterns. Animals are not capable to do that. So that's the main difference, and that's what you see here. That's the execution of human intelligence at the high level. Detecting common patterns, writing them down, and allowing us, who just read Mitre-Attack, to follow these patterns. So following the patterns, that's one part of intelligence, but detecting them and writing them down, that's like a higher form of intelligence in my understanding. Okay, but that's so far for detection. So let's go to editing mode. And the next and last thing we want to do is, as usual, we will take a look at references. And there are a lot of references, so I will copy, let's say, this amount. Let's take a look at this. Yeah, that worked fine. We have 71 references in total here. Let's switch back. So we have here Mercer, that name I've seen. Olympic Destroyer takes aims at Winter Olympics. Then we have Novetta Research Group, never heard of them. Michael Dawson, Scissor again, Stop Ransomware, Akira Ransomware retrieved. I like that. So since I faced Akira, I would like to read that paper. The Nutland, Akira again. Sama used. It's a lot of ransomware here. Sentinel-1 is there. And then Scissor, understanding ransomware threat actors. I like that too. So Scissor is doing a good job. I'm creating a quick little video right now on the topic insider threat and insider espionage. So the video will be on the channel soon. But in that context, Scissor has interesting sources as well, and also the FBI is doing. The FBI is doing an outstanding job, and yes, they are a secret agency somewhat, but they provide good information to the public too. And I'm not even sure, is the FBI a secret agency like the NSA? I'm not even sure, so they cannot be that secret because they work under the law and they have a lot of public resources, but yeah. NSA works under the law too, by the way, but they are more secretive. Yeah. Anyways, Scissor and FBI, that's a good educational content, and we will look into this. Yeah, so far so good. So that's a quick little 15-minute video. So we now looked at service stop, a simple technique, but nonetheless often forgotten. Start with the simple things and then move on to the more complicated stuff. It is in the impact step of the kill chain. We understand a little bit what it is, what is the goal. Just render services unavailable to legitimate users. We have some procedure examples. They are connected a lot to ransomware, as it looks like. Mitigation, we also understand. These are the classics: segment your networks, user account management, and many more. The detection strategy just comes down to detecting one behavior chain, and that's what they did here at Mitre. You can follow that as a detection engineer instead of being creative yourself, right? And some sources that catched my eye, so we know who is researching on that. It's not surprising to see Sentinel-1 here in this list. The other names I don't recognize, but CISA FBI, that's fine. Yes, so far so good. Thank you for watching, people, and as usual, thank you for spending time on cybersecurity. It is time well spent. See you in the next video. Goodbye.